Okay, so in the previous video we were looking at how to solve a system of inequalities, and the inequalities were all set up to be in slope-intercept form. Well, what we're going to be doing today is solving systems of inequalities when they're in standard form. Now we've looked at in a couple lessons ago, in lesson 5-7, there was a part there where we graphed just single inequalities in standard form. So we're just building on top of that. We're going to do it the same way. We're going to use our x and y intercepts. And when you're doing your work, I want to see what your x and y intercepts are. So make sure to write them down for each equation, or for each inequality. So let's just start by looking at these first two examples. So our first one here, if I want to find my x-intercept, I'm just going to focus on what the x is. So to solve this, I would take -4 divided by 2. And -4 divided by 2 is -2, so my x-intercept would be -2. To find my y-intercept, I cover up the x because the y-intercept is when x is 0. And when I do that, I get y is -4. So my x-intercept is -2. My y-intercept is a -4. Now we want to come up with some more points here. So remember my rise over my run. To go from this point on the x-axis to the y-axis, I'm going to go down, because this point here is furthest to the left. So you always start with the point furthest to the left to find your slope. So it's rise over run, so I go down 4 to the right 2. So I could go down 4 to the right 2 to come up with some other points. Or go up 4 and to the left 2, up 4 and to the left 2. So the more points we have, the better. We could have also said, since it's going down 4 and over 2, if I reduce that, it's the same as -2 over 1. So that would have given me, if I go down 2 over 1, down 2 over 1, and so on, that would have given me some other points here to graph to even be more accurate. Well, that's how we can use or find our slope here. Remember, we always look, before we connect these, to see what kind of line we use. We want to use a dashed line. So I'll make sure I use a dashed line here. Now remember what we talked about when we did equations in standard form. We always pick a point not on the line to see what region we would shade. So and if possible, which is going to be most of the time for these problems, use 0, 0, because when you do that, when I put 0 and 0 in here for x and y, I get 0 is greater than -4. Now that is a true statement. 0 is bigger than -4. So I'm going to shade in the area, I'm going to shade in the region that has 0, 0, because 0, 0 is a solution. So all the points in that region are going to be a solution. So I want to make sure that 0, 0 is shaded in. Okay. But remember, we're trying to see what region these two inequalities have in common. So now I'm going to focus on the other inequality, starting with finding my x-intercept. So to find my x-intercept here, I cover up the y, so the x-intercept would be -8. To find the y-intercept, I cover up the x. Now this is a -y equals -8. So to find the y-intercept, you could do one of two things. Some people like to look at this as being a -1. So we just divide both sides by -1, so I get a y-intercept of a +8. Or some people have been taught to look at this where you just take and change this to be positive, so we change the other one to also be positive. So it'll be y is a +8. So my x-intercept is -8. My y-intercept is +8, meaning my slope would be, I'd go up 8 over 8. Well, 8 over 8 is simplified to just be 1. So my slope here would be 1. So I go up 1 over 1. And here I would use another dashed line. And to see if I shade above or below here, I would put 0 in for x, 0 in for y, so I get 0 is less than -8. Well, 0 is not less than -8. So the point 0, 0 is not a solution. It's a false statement. So I want to shade in the region that does not contain 0, 0, which is the region up here. So that would be my feasible region. That's our goal. We're looking for, again, what region they share, what region they have in common. So let's try another one together. Again, we want to find out what our x and y intercepts are. And just like I mentioned earlier, I want you to identify what your x and intercepts are when you're doing your assignment, and when you're doing your quiz, and when you're doing your test. So that way I can see where you're making your mistakes. So our x-intercept here, again, I'm going to focus on just this first inequality and just focus on the x. So my x-intercept is going to be -6 divided by 3 gives me -2. So now to find the y-intercept or cover up the x. Now make sure you don't accidentally cover up that minus. So that minus is crucial to getting this right. Because this is a negative 6, this is a negative 2. Negative 6 divided by negative 2 is a positive 3. So I have my x and y-intercepts. My x-intercept, again, is negative 2. My y-intercept is a positive 3. My slope here, I go up 3 over 2, up 3 over 2, up 3 over 2, or down 3 to the left 2, down 3 to the left 2. And I would use a dashed line here. Okay, now to see if I shade above or below, I'm going to use the point 0, 0. So if I do that, I get 0 is greater than negative, is greater than negative 6. And that turns out as a true statement. 0 is bigger than negative 6. So that means the region that contains 0, 0 is going to get shaded in, because since 0, 0 is a solution, since it gave a true statement, all of them in this region are going to be a solution, or would make a true statement. Okay, so I want to shade that in. But again, this isn't my answer. I'm looking for the common region between these two. So now I'm going to find my x and y intercepts for my other inequality. So my x-intercept is going to be when y is 0. So that means that my x-intercept is 6. My y-intercept is when x is 0. Again, I don't accidentally cover up that negative, because now 6 divided by negative 2 gives me a negative 3. So now when I go to graph this, my x-intercept is 6. My y-intercept is negative 3, meaning I go up 3 over 6, or down 3 to the left 6. Or I could even say up 1 over 2, up 1 over 2, to get some more points here. But otherwise, I want to make sure I connect these and use a solid line. Oops. Close enough. So again, I want to figure out which region it's going to be. It's either going to be in this one or it's going to be in this one. I don't know. So to figure that out, I'm going to pick a point, not on the line. Again, 0, 0 isn't on the line, so I can use that. And I get the statement 0 is greater than or equal to 6. 0 is not greater than or equal to 6, so that means 0, 0 is not a solution. That means I would shade in the other region. So that would be the region down here. So this would be my feasible region. This would be the region that you want to make sure is shaded in darker, because I need to identify the fact that this would be where our common solutions would be from, not from that other side. So your answer should look more like this. Okay. So why don't you guys take a minute and work on these next two examples on your own. So why don't you pause the video and hit play when you're ready to check your answer. Remember that if you have a version, or if you have an equation like this, x is less than or equal to 6, that's going to be a vertical line, and this will be a horizontal line, just to remind you. So take a few minutes to work on those, and again, hit play when you're ready to check your answers. Okay, so here's what you should have gotten for these. With this first one, this is a vertical line going through where x equals 6. It's going to be a solid line. And since it's less than, with these, you can either, these are easy, you don't have to use the number trick. You can by putting in 0. Otherwise, if it's less than or equal to 6, it's going to be to the left of 6. It's going to be left of that line. This other one would have had an x-intercept of -3, which is here. It would have had a y-intercept. -6 divided by -3 would be a +2. So here you say you have a slope of 2/3, up 2 over 3, up 2 over 3, up 2 over 3, and so on. And again, we would have used a solid line, as you can see that they did. And the reason why you shade below, because remember, we can't look at this, because if you look at that, it would, if it's in slope-intercept form, we would shade above, but it's not in slope-intercept form, so we don't want to use that little trick. We have to use the fact that we're going to use the point 0, 0, and see if this is a true statement. 0 is greater than -6, so that means we're going to shade in the region that has 0, 0. It's a true statement, so I shade in everything below that line, everything to the left of the other line, so the common region would be what's shaded in that pink there. And with the other one, we have y is less than or equal to -8, so it's a horizontal line going through -8. Again, it would be a solid line, and we would shade below that line. Then we graph the other one. The other one has an x-intercept That's a positive 1. So right here. It has a y-intercept of negative 2, because remember, this is a negative y, or a negative 1, the way I like to look at it. So we divide both sides by negative 1, we get negative 2 as our answer. So that means our y-intercept is here at negative 2, so my slope is up 2 over 1, up 2 over 1, up 2 over 1, or down 2 to the left 1, down 2 to the left 1. And so you can get a better idea of what the graph looks like. It should be a dashed line. And if I put 0 in here, I get 0 is less than 2. When I look at that, 0 is less than 2. That is a true statement. So that means that I would shade in the region that would have 0 is less than 2, which would be this whole region. And again, we're shading below the other line, so that means the common region is what they have down here. So hopefully you got those right, and if not, hopefully you caught your mistake so you can understand how to do your lesson when you have these inequalities in standard form.